an AI augmented software development platform designed to transform the way engineering teams build, debug, and optimize software. It's an event driven system powered by OpenAI GPT 4o and O3 Mini, orchestrated through LlamaIndex workflow. What makes DevX powerful is that you can start with a simple requirement and it guides you across every stage: user stories, design, code, DevOps, and test cases with feedback loops built in. Let's take a moment to walk through how DevX actually works step by step. It's designed with just one thing: your requirements. That's the only input you need to kick things off. From there, DevX orchestrates a sequence of intelligent role-based steps, kind of agents, each with a specific purpose. First thing, DevX Product Manager creates detailed user stories from your requirement, and after every step you have a full control. You can either give feedback and regenerate, move to the next step with a specific instruction, or just stop the flow if needed. Next, the DevX software architect builds out the system design. The DevX software engineer then generates the application code. The DevX DevOps engineer configures CI/CD pipeline, and finally, the DevX test engineer creates the test cases to validate everything. What's magical here is you don't write any prompts. DevX just take your requirement and intelligently produce artifact at each step. Now under the hood, each step is currently powered by direct OpenAI calls using LlamaIndex. But these roles already behave like early stage agents with clear goals and responsibilities. And in future iterations, we will evolve them into true AI agents with RAG integration, memory, and contextual reasoning. This would allow DevX role to remember your past decisions, collaborate across stages, and align better with your organization standards. So, in short, DevX is a feedback driven, event driven, and getting smarter with every iteration. It is a true step towards AI augmented software development. Let's first list down all the required Python libraries and import all the necessary Python. For the running this notebook, you will require OpenAPI key and access for the GPT-4o Mini and O3 Mini model. Now, what powers DevX? At the heart of DevX are three powerful components: Llama events, Llama workflow, workflow runner. Llama events, intelligent interactions. Llama events are foundation of DevX agentic flow. Each event represents a specific action or interaction that occurs in the software development lifecycle. Every major design, development, DevOps, QA is modeled as an event. Events also carry feedback, enabling bi-directional communication with the user. These are not just data containers. They serve as a triggers for agents to respond, iterate, and evolve the solution collaboratively. Second thing is the Llama workflow, the brain of DevX. The core logic of DevX lies in a class called AI DevOps workflow, which inherits from LlamaIndex powerful workflow system. Each step in this workflow listens for a specific type of event and process it using the OpenAI model. For example, when the product manager event is triggered with a requirement, the system generates the user stories and then emits the next event for the design. The workflow supports asynchronous and reactive executions. This makes DevX flexible and modular. The new steps can be added, skipped, or looped based on the feedback. It's like building a team of virtual engineers, each with its own expertise working together in sync. So this is a full class for DevOps workflow. Now, third component is the workflow runner. To glue it all together, we use a workflow runner. It's a background thread and kicks off the workflow, feeds input, listen for new events, and handle real-time interaction with the users. The runner creates an event loop that manages the lifecycle of DevX session. It streams each step's output, live into the UI, waits for user feedback, and passes it back into the workflow, creating a true human in the loop AI system. For instance, if a user reviews generated design and wants to changes, they submit feedback in the Gradio UI. This feedback is turned into a design feedback event, which the workflow processes to regenerate improved output. Then we have some callback methods which will be called when user clicked some of the action on the UI. Finally, we build a nice user friendly UI using Gradio, using some custom CSS. Now if we run this cell, it will create an UI. That's wrap up our Jupyter Notebook walkthrough. In the next part, I will show you how this logic integrates into beautiful and interact Gradio based UI that makes DevX usable by any developer without writing any prompt. Thanks everyone.